Before we start, subscribe to Zenith Tech, like this video, and share it with anyone who wants to understand how the internet delivers websites, videos, and files so quickly. Have you ever wondered how a website can load in just a few seconds even when its main server is thousands of miles away from you? The answer is a technology called a CDN, or Content Delivery Network. A CDN is a network of servers distributed across different locations around the world. Its job is to deliver website content from a server that is geographically closer to the person requesting it. So how does this actually work? Imagine you are visiting a website whose main server, also called the origin server, is located in the United States, but you are accessing it from Egypt. Without a CDN, your request may need to travel a long distance to reach the origin server. The server processes your request, sends the data back, and that information travels across multiple networks before reaching your device. The farther the data has to travel, the more latency can be introduced. This is where a CDN becomes useful. Instead of making every visitor connect directly to the origin server, a CDN creates a network of servers called edge servers or points of presence, often located much closer to users. These servers can store copies of frequently requested content such as images, videos, JavaScript files, CSS files, and other website resources. This process is called caching. Let's say a website has an image that millions of people want to view. The first time someone requests that image, the CDN may retrieve it from the origin server and store a cached copy on an edge server. When another person nearby requests the same image, the CDN can deliver the cached version directly from that nearby server instead of requesting the file from the origin again. This can dramatically reduce the distance the data needs to travel. But how does the CDN know which server should respond to your request? When you visit a website using a CDN, the network can determine an appropriate edge server based on factors such as your location, network conditions, and server availability. Your request is then directed toward an edge server that can efficiently deliver the content. For example, imagine a company has its main server in the United States but has CDN servers in Europe, Asia, Africa, and other regions. A visitor in Germany might receive cached content from a European edge server. A visitor in Japan might receive it from an Asian edge server. And a visitor in Egypt could potentially receive it from an edge server closer to their region. The important idea is simple. Instead of sending every request across the world, the CDN tries to serve cached content from somewhere closer to the user. This reduces latency. Latency is the amount of time it takes for data to travel between systems and for a response to come back. Lower latency can make websites feel much faster, especially when they contain many resources. But speed isn't the only advantage of a CDN. CDNs can also reduce the workload on the origin server. Imagine a website suddenly becomes extremely popular because a video goes viral. Without a CDN, millions of requests could potentially hit the origin infrastructure. With a CDN, many of those requests can be handled by edge servers using cached content. The origin server doesn't have to repeatedly send the exact same files to every visitor. This can help websites handle large traffic spikes more efficiently. CDNs are especially useful for websites with large amounts of media. Streaming platforms can use them to deliver video content. Online stores can use them to quickly deliver product images and website resources. News websites can use them when millions of people suddenly visit after a major event. Even simple websites can benefit from faster delivery of images, scripts, style sheets, and other files. But what happens when the content on the origin server changes? This is where caching rules become important. A CDN doesn't necessarily store a file forever. Content can have an expiration time, often called a time to live, or TTL. When cached content expires, the CDN can request a newer version from the origin server and update its cache. Website owners can also configure rules that determine which content should be cached, how long it should remain cached, and when it should be refreshed. There is another important benefit: reliability. Because a CDN has many servers distributed across different locations, traffic can potentially be redirected if one server or location experiences problems. This doesn't make a website completely immune to outages, but distributed infrastructure can improve resilience. CDNs can also provide security features. Many CDN providers offer tools that help protect websites against certain types of malicious traffic, including large-scale DDoS attacks. Instead of allowing all traffic to reach the origin server directly, the CDN can act as an additional layer between users and the website's infrastructure. So let's put everything together. You open a website. Your request is routed through the internet toward the CDN. The CDN determines an appropriate edge server. If that server already has the requested content cached, it can deliver it directly. If the content isn't available in the cache, the CDN may request it from the origin server, deliver it to you, and potentially store a copy for future requests. This entire process can happen extremely quickly. And that's one of the reasons modern websites can serve content to users all over the world without requiring every visitor to connect directly to one central server. So, in simple terms, a CDN makes the internet faster by bringing frequently requested content closer to the people who need it. Instead of one server trying to serve everyone from one location, a CDN distributes content across a global network of servers. The result can be lower latency, faster loading times, reduced origin server workload, better scalability, and improved reliability. The next time you open a website and an image appears almost instantly, a video starts quickly, or a page loads in just a few seconds, there may be a CDN working behind the scenes. You don't see it, but it is one of the technologies helping make the modern internet fast and scalable. If you enjoyed this explanation, subscribe to Zenith Tech, like the video, and share it with someone who wants to understand how the technology behind the internet actually works.